All right. Now let's do the let's start from the beginning. We're gonna do this one first and find out if the my computer has enough speed and bandwidth to make this scene and be able to control this conveyor and stop it right at the end of the conveyor where the sensor is located, and see if it stops the load after a little bit or before a little bit. Well, before maybe not, but after it should. So let's go ahead and start a new project here on connected component. I'm going to click on new. I'm going to put it on my let's just put it on my desktop, right here. Add device on create. Cool. Let's go. Now, since we're using the simulator, I do not have any PLC with me, so let's just configure the simulator right now so we can work on it right away. So I'm going to go ahead and controllers, and then I'm going to choose micro A50, and then I'm going to use this one over here, which is the simulator. I'm going to go ahead and select it. This is the version I have installed, the latest one. So I'm going to add it to the project. So once that's done, we're going to go ahead and just create one simple program, because this A to B scene on Factory IO is just extremely basic. So we're going to go ahead and do it pretty quickly. So, all right. So right click on your project organizer, right click on program, select add ladder diagram. I'm going to call a conveyor. And I'm going to double click on my local variable. And I'm going to create just one variable only. It's going to call step. This is the variable I always create to be able to program step-in logic sequencer. This is the only thing I need. And I'm going to do it, the dimension is going to be local variable. I always want local variable because I can use this name everywhere, all the time, on every single program. So let's go ahead and double click on conveyor. And let's start with the logic. See what happened. So right here, if we go to Factory IO, we're going to go ahead and see which variables or tags Factory IO is giving us. So let's just start a project and see what the driver has for us. So we're going to choose MicroLogix 800. So here we go. This is what I'm talking about, the tags. Boolean in, this we have to create these tags right over there at CW. So let's go ahead and configure it. I'm going to go for 129. Let me see if this is what we have over here. Let's go to my tools, Micro 800, a simulator. I'm going to go ahead and just turn it on. That's all we need. That's why if you go over there, that's why Factory IO were not able to see it, because you just have to power it on. That's it. I always do this just to make sure that we have connection and we can actuate input and output. So we got power on, light, and we got the wrong condition. Good. Let's move on. So back in Factory IO, we already have this IP address that we're going to put over here. Auto connect, and this for now it looks just fine. Go ahead and configure, get out of the configurator to see if you're able to connect. And you shouldn't, of course, because you have no idea. He's looking for the tags, and Factory IO will not connect unless you have created this tag. So let's go ahead and create two tags, boolean in 0, boolean in 1, and they has to be, remember, global variable. Anything coming from factory.io has to be global variable. So let's go ahead and do insert record. So what we're going to call it? What we're going to call it bool in 0. So caps bool in 0. And this is going to be a boolean. So let me copy and paste over here so we can do the next one. So the next one is going to be number 1. And for the output, so we're going to do out 0. That's all we need for the output. So I always like to put the names on tags. I like to alias them because I can refer to them quicker and easier. So let's go ahead for 0. Let's go ahead and put sensor. All right, sensor caps, or like caps sensor. Boolean 1 is going to be running, just a confirmation from factory.io that I'm running. Okay, so it would be factory.io running. And the last one is going to be an output, and that's for the conveyor. So we're good. So we got the conveyor. Factory.io is still searching and saying, hey, I cannot find anything. What's going on? Don't worry, it's okay, don't worry. So let's get out of here. And back over here. So we're gonna do a simple routine. We're gonna call this, I'm gonna go ahead and drag, bring this baby over here, drag it over there, and release it. And the first thing I'm going to do is just select. Why sometimes I like to just get out of here and directly just start typing my variables. So I got step, the one we just created. So let's get step 0. Actually, yeah, that will be my start. Let's just step 0 will be my start for now. Just for now. That's my start. So if I click on step 0, or I start my bit step 0, and then my step 2 is not done. So I'm going to go ahead and latch my bit, which is step 2. Step 1, I'm sorry, step 2. I should be step 1, I made a mistake. So it should be here, step 1. It should be 1. All right, we're good to go. So after that, I'm going to go ahead and clicking over here on the load on the latch. I'm going to press Control number 7. That is going to create a branch. So I'm going to go ahead and copy this one and click right on this dot over here and paste it right there. So what do we have here? So we got conveyor. So I'm going to go ahead and latch the conveyor. All right, we're good to go. So let's go ahead and do the second one. I'm going to copy and paste, but I don't like to see this orange stuff. So what I like to do is just go ahead and right click on it. Sometimes it takes a little long. And then I'm going to go display comment false. That way I don't have that yellow line over there hanging in there. So next step would be step 1. If step 1 is made, but step 2 is not, go ahead and latch step 2. And we are going to put our sensor here, because this sensor has to be the one that will stop the load. All right. So I'm going to go ahead and copy this and paste it over here and drag it over there. Click on it and start typing sensor. There you go. You found it. So if well, I made a mistake here. I put a latch. It should be an on latch. So I'm going to go ahead and unlatch this. This one would be my, I'm going to look on my global variable, and I'm going to select conveyor. Okay, good. So this is a simple program. It's a step-in logic. I know I use step-in logic for something so simple, but I always program complicated stuff or easy stuff with step-in logic. It doesn't matter how simple it is, because sometimes it gets simple and then in complexity it increases really quickly. And then I found myself going back to step-in logic. And I decided to, well, from now on, it doesn't matter how simple the project is or how difficult it is. I am going to use step-in logic. All right? All right, good. So let's go ahead and I think that's enough. The conveyor should start when I go ahead and click on this one and toggle it. I will manually toggle this one later on when I have connection. And then I should be able to do this. So, all right, one more thing. We need to add a way for these stepping bits to turn off, because if they stay on, the routine is going to run over and over and over again, and we do not want that for now. So I'm going to click on this middle instruction, press Control 7. That will give me a branch. And here I'm going to go ahead and look for my move command. And where am I? Move. That would be over here. Let's see. Move, right? And I'm going to grab it and bring it over here. And what this is going to do is just zero in all my step-in logic bits. That's all there is to it. That's all I want. Okay. So before I download it, let me just go ahead and click build to see if I have made any mistakes. I always like to do that because build it's much faster than if you go ahead and click on download, because download is going to build it. Of course it will, but the problem is that it's going to take such a long time, and if it finds a bug, you just have wasted my time. So over here I got my build succeed, so that looks pretty good. So let's go ahead and download the project. Everything looks good. Go ahead, whatever. If we made a mistake, we'll correct it. All right, let's do it. Let's go ahead and download the project. We are going to, okay, let me see. Yep, I think we're ready. All right, let's go ahead and download the project. We already have the path. But if you don't have the path, what you're going to do is just click on it, click on this edit mode, and then select your path over here, okay? So let's go ahead and browse and see what RS-Link it's able to see on our network. So as you can see, we got .2 micro A50, but the one that we are connected to right now is the 001, as I already told you. So let's go ahead and download. Let me see, let me just confirm. Yep, this is the one, 127.0.0.1. So let's go ahead and click on download. We're going to download this two piece of lime, 2 runs, and see what happened. So the download takes a little while. I have seen that it doesn't matter what number of runs do you have, what number of programs. It always takes like too much sometimes. Right now we got build succeeded. I'm looking at right here on my yellow blue line. And we got a warning, of course, to download. I always download with project value and click on it. And then we started downloading the resources to the PLC. When you finish downloading, the program is going to take you right to the tab that you were working on. Once you click on remote run, the background is gonna change from white. It's gonna change to orange, sort of like an orange color. All right, succeeded, 0 failed. I think we're ready to run. This is the color I was talking about. So we're online because you can see red and blue. Blue, those are bits that haven't been made yet and normally close, those one are the one we do. Now, this sensor might have to change it, because over here, I think the sensor is, let's just check. If we go over here and connect, let's see what happens if we are able to connect. Yep, we did. So once we get this green check mark right next to our protocol, the connection, PLC, then we're good to go. So let's go ahead and click on back arrow and find out what this sensor is all about, right? I think I already told you that you have to click over here to be able to run this sequence. Let's go ahead and do that. Let's see which angle we're going to start with. Let's start with that one. And click on view and dock all tags. And you see, the sensor is normally closed. So if we start this sequence right now, it's not going to work and this baby might go to the ground. So let's go ahead and do it. All right, let's go ahead and click here. And maybe I want a normally close. And let's just write sensor. Click on this one and delete. And then I think we're pretty good. We're ready to go. So let's go ahead and download this right now to the PLC. I do have the PLC. Yes, download with project value. Okay. Meanwhile, we're going to go ahead and while this is taking place, let's go ahead and open up Factory.io and let's just create this scene again. One more time. This time we're going to do it from scratch. Okay, remote run. And then let's just click on scenes and let's select A to B. Right here, we're going to go to File and Drivers, and we're going to select 800 as our PLC driver. The host is 127. Yeah, that's the one we already had configured right over here on a micro 800 simulator. So let's go ahead and connect, see what happened. Cool, we got a check mark. Okay, again, so we're ready to go. No problem, let's do it. So over here, I believe we are ready on, yep, we are live with the PLC. So let's just go ahead and double click, toggle this value and see what happened here. Yep, once we run it, it should stop when it sees the sensor. Good, so let's do it again. Let's just reset the simulation and go over here and toggle the value again. Cool, so it works just fine. Now, there's one little problem that I have to go back and forth between programs and activate here, toggle over here, and this is becoming a little bit troublesome and not efficient. So I'm gonna go ahead and show you how to program these babies over here. So we could just hide this screen over here and start the scene and the production from this baby, and maybe use this other one to reset, to do maybe this button remotely. We have to activate this instead of me doing it manually. I'm going to go ahead and program this 01 for my reset and 00 to start the conveyor and run all the way down to the end. All right, I think I'm going to go ahead and do that. All right, let me show you how to do that. All right, let's do that right now. First of all, what we need to do is to increase the number of I/O here in factory I/O. So let's go to drivers. So you see we only got 3 of them, and we really need this baby over here. This is called factory I/O reset. So if we grab it and put it here, there's no way we could do that, because we ain't got we have to create an additional Boolean value. So let's just disconnect and click on configure. And over here, we're going to increase this Boolean outputs to 2 instead of 1. So now we have an additional one here, so we can go ahead and grab it and grab the factory IO reset and just drop it over here. That's exactly what we need. Now, over at my PLC, I have to create a tag, and that tag has to be created as a global variable. So let's go ahead and create that and put it over here. Maybe I want my IO. Let me copy this one, paste it over there, and click it and change it to number 1. I'm going to go ahead and also copy this name so I don't have to type so much. Put it here and then change the name to reset. That will be factory IO reset. All right, now we are going to get rid of this baby, and instead we're going to put factory IO running. That will be my bit telling me that the entire application is in run mode, at least. Factory IO it's on run mode. Now I need another one so I can start my simulation. So we're going to use for this one, we're going to use input 00. That will be my start. All right. So in other words, if I click on input 00 and factory IO is running and this step hasn't been made, bingo, boom. You latch my first running sequence, my stepping logic, plus you start the conveyor, right? So in order for me to reset the scene, I have to create another run. Let's just go ahead and grab it and grab one over here and put it right there. Don't like this yellow stuff, so let me go ahead and get rid of it. I really dislike it. So let me go ahead and go to property and display comment. I'm going to double click it to false. All right. So good. Now the input that we need, let me just copy and paste it over here. And this is going to be changed to factory IO. Actually, no. This is going to be input 1, as I told you before. So let's go ahead and use input 1. So if I click on input 1, I should be able to do an OTE. Let me grab one of those and put it here. And then we can change that to reset, factory IO reset. So that was going to be my OTE. So I think this is good. So that's all we need to add. One single run and just 2 bits. So let's just go ahead and save this and send it to the PLC. All right. Over here, while this is taking place, I think we are pretty much done on my factory IO, right? Yep. I got my reset. I got my factory IO running. This is the bit that we added it. So let's go ahead and wait for the PLC to now load, and then we're going to connect to it, right? Okay, always choose download with values. If you want to override those values on your programs with the values that you have on the PLC already stored. All right, let's go to run mode and test this application. And yeah, let's see what happened. Let's see if this driver can connect to it now. Sure, it did. So we got the check mark, green one. Those Booleans values are being seen from the PLC. Just go ahead and put it in run mode. So when we do that, let's just wait until we go to online with the PLC. That takes a little while. But as you can see, my factory IO is running. So if I go ahead and turn off, stop it,
it should be, you should be able to see it over here on my PLC. You see, it's already stopped. So let's go ahead and try it. I'm gonna go ahead and put it in run mode. And this baby, I'm gonna go ahead and put it right over here so it's hardly can see it. And then toggle, I'm gonna toggle 0, 0, and then click on it again so you turn it off. Bingo, that's what it did. It did exactly what we needed it. Now we don't have to go back and forth between those programs. Just go ahead and reset this scene over here. Just click on 0, 1. That resets the entire scene, and then you were able to run it again. Good. Now to finish up this video, I want to show you something. This is a little problem you're gonna come across. Let me reset the scene. Gonna come across this little problem. It's the bandwidth or the speed between communication from your PLC simulator to factory I/O. Okay, let me show you something. Let's just start the scene again. Bingo. All right. Let me just zoom in a little bit. Whoops. I moved the load, and I didn't mean to do that. So let's do it again. All right. Good. Now watch this. I'm going to do it a couple times so you see the alignment between this sensor and the load. In other words, where the load stops, it's inconsistent. Why it is inconsistent? Well, because of the speed of communication between the drivers. The factory I/O driver speaking to the simulator's driver. And that takes a little while. And sometimes you see right over here, this is the leading edge of my sensor versus this leading edge over here. Watch, let's do it again and see if it stops in the same place. I can assure you that it would not stop in the same place because of the lagging in communication. All right, you see, it went a little further forward. Let's do it one more time and let's finish it up. Look where it stopped. From here, it was the first time it stopped here. Now it's stopping right on this leading edge as compared to the leading edge of the sensor. So just the one last time, and then we're done. All right, let me reset the scene, start it again. Now, the reason, hold on one second. Let's just wait until it stops. Bingo, you see? It never stops in the same place. And this, it's okay. It is not a problem with factory I/O. It is not a problem with micro 800 simulator. It's just the lag in communication between the drivers, okay? Take that into consideration when you are programming. Sometimes the load is gonna stop a little further behind, a little further in the front, or it's gonna be a little, actually it's not going to be in the exact position all the time. So take that into consideration and program your way around it, and it's gonna work just beautiful, all right? All right, guys, this is it. Thank you for watching. I'll be doing another scene later on and post it in YouTube when it's ready. Thank you. Bye-bye.